All right, let's get right into it. If you're running a professional operation, you know the deal. Efficiency, safety, and the bottom line are everything. So today we're breaking down the 2025 guide on laser paint strippers to help you figure out if this tech is actually the right investment for your business. For years, the choice has been between a couple of messy, hazardous options. You got sandblasting. Sure, it's fast, but you risk damaging the surface underneath, and you're creating a mountain of waste. Or you've got chemical strippers, and that means toxic fumes, long wait times, and a hazardous waste nightmare. Well, laser technology presents a whole new way of doing things. It's a non-contact, super precise process that's safer, faster, and get this, it produces 90% less waste. So here's how we're going to tackle this. Think of it like a funnel to help you make the right call. We'll start with the challenge, see if a laser even makes sense for you, peek under the hood at how it works, help you pick the right tech, cover safety, which is super important, and then, of course, run the numbers on your return on investment. Okay, section 1. Let's start by quickly nailing down the problem we're all trying to solve here. Because the old ways of stripping paint, well, they come with some serious headaches that go way beyond just getting the paint off. So let me ask you, does this sound familiar? You're dealing with constant exposure to nasty chemicals, you're paying a fortune for hazardous waste disposal, or you're just losing hours to slow, back-breaking manual scraping and sanding. These are the exact pain points that are pushing pros like you to look for a better way.
Now for section 2. This is our first and most important filter. Before we dive into all the technical stuff, let's figure out if you should even be considering this technology for your workload in the first place. The 2025 guide gives us a really clear benchmark. If you're removing paint from more than 200 square feet of surface area every single month, you are smack in the middle of the zone where the economics of buying a laser start to look really, really good. If not, hey, don't worry, there are other options.
So this brings us to a really quick decision framework. Buy, rent, or skip. You should be seriously thinking about buying if you hit that 200 square foot number, or if you work with hazardous stuff like lead paint, or if you just need incredible precision. Now, if you've got a single massive project, or you just want to test the waters, renting is a fantastic option. But honestly, if your volume is under 50 square feet a month, the guide's pretty clear. You're probably better off skipping it for now. The upfront cost just won't pay off. All right, section 3. If you're still with me, it means this tech might be a fit, so it's time to understand the magic behind the machine. Knowing how laser ablation actually works is the key to trusting the process and getting amazing results. It's really a beautifully simple 4-step process. First, the laser fires these incredibly short, powerful pulses of light at the surface. Second, the paint or the coating just soaks up that energy, heating up thousands of degrees in microseconds. Third, this intense, super rapid heating makes the paint vaporize. It goes directly from a solid into a gas. That process is called ablation. And finally, an integrated fume extraction system safely captures all those vaporized particles, which keeps your workspace clean. So how does the material underneath stay perfectly unharmed? Well, the key is this concept called the processing window. Think of it this way. Every material has a cleaning threshold. That's the energy needed to vaporize the paint. And it has a damage threshold. The lasers are precisely tuned to operate right inside that window, delivering just enough energy to get rid of the coating, but staying safely below the level that would damage the good stuff underneath. It's all about precision. This brings us to section 4. And this is maybe the most critical technical decision you'll make. Not all lasers are created equal, and choosing the wrong type for what you do can be a very expensive mistake. So the big question comes down to this: pulse or continuous wave, also known as CW. The answer depends completely on what you're working with. This isn't about which one is better overall, but which one is right for your specific materials.
Let's break down the key differences. Pulse lasers fire in short, high-energy bursts. That means very little heat actually builds up on the surface. This makes them absolutely perfect for delicate materials like wood, composites, or for any high-precision job. Continuous wave lasers, on the other hand, emit a constant beam. They're generally cheaper per watt, and they're fantastic for just blasting rust off thick metal. But that constant energy input creates a lot more heat, making them a total no-go for anything that's heat-sensitive.
And that brings us to the most important rule from the guide. I want to be absolutely crystal clear on this. If you work with wood, or even think you might in the future, a pulse laser is mandatory. A CW laser will scorch and burn the wood. This is the #1 mistake new buyers make, so please remember, wood requires pulse. No exceptions. Now, let's talk about something that is never, ever optional: safety.
We're in Section 5, and operating this equipment requires you to be a pro and stick to the safety protocols.
This is not a suggestion list, it's a list of requirements. You need laser safety glasses that are specifically rated for your laser's wavelength. You absolutely must have a fume extraction system, especially if you're working indoors. And you need a clearly marked, designated work area with a fire extinguisher nearby. These are the non-negotiables for operating safely.
And let this sink in. Even brief exposure to reflected laser light can cause permanent eye damage. Regular safety glasses are not sufficient. Your eyes are irreplaceable. Your standard safety glasses will do absolutely nothing. Using the correct wavelength-rated protective eyewear is the single most important safety rule, period.
Okay, we've covered the technology, the types, and the safety. Now for the final filter, the one that gets the purchase order signed. Section 6, calculating your return on investment. Does this machine actually pay for itself?
Take a look at this number, $23,100. According to a case study in the guide, this is the annual savings a typical fabrication shop can expect starting in year 2. So how did they get there?
The breakdown here is pretty compelling. This shop was spending almost $2,500 a month on chemicals, the labor for stripping, and waste disposal. After they invested in a 500-watt laser, their monthly cost plummeted to just over $500. That's a saving of over $1,900 every single month, which allowed the machine to pay for itself in just 9.4 months. Incredible.
So this all leads to a final rule of thumb from the guide. When you run your own numbers, and you absolutely should, if the payback period comes in under 18 months, laser technology is almost certainly a clear financial win for your operation. It's a no-brainer at that point.
And that leaves us with one final thought. As you do your own calculations, I want you to ask yourself, what is the true cost of your current process? And I don't just mean the price of the chemicals or the sandblasting media. I mean factor in the hours of lost productivity, the cost of regulatory compliance, the long-term health risks to your team, and the price of waste disposal. When you add it all up, you might find that the cost of not upgrading is a lot higher than you think.